we're going to talk about everyone's favorite reaction, combustion. Most of us have heard of combustion, but what exactly is it? Well, the standard definition is a reaction in which a substance reacts with oxygen gas, releasing energy in the form of light and heat. So that means it produces more energy than it takes in, making it exothermic. A lot of times we see it occurring with hydrocarbons. So we have something here that's a hydrocarbon that contains carbon and hydrogen with oxygen, makes carbon dioxide and water. That's water vapor and a whole lot of heat. A simple kind of combustion reaction, you have natural gas, which is methane, and oxygen. So here's methane, the black is carbon, and the white is hydrogen, and the red here is oxygen. So we have one molecule of methane and two molecules of oxygen. So what happens during the reaction So there we have carbon dioxide. So it produces one carbon dioxide molecule and two water molecules. Bunsen burners use natural gas. You can see here I'm lighting the Bunsen burner, and then I adjust the air vents to allow more oxygen into it so we can get a hotter flame. We have the same kind of thing when we have the combustion of acetone. So here's our acetone again. Now again, red is oxygen, black is carbon, and white is hydrogen. Then we have four O2 molecules here. And then they just kind of rearrange themselves. So then after we've rearranged it, we have three carbon dioxide molecules and three water molecules. Also, I've put the states of matter here. Acetone is a liquid, so we do an L, but we do it in cursive so we can tell it's an L and not a 1 or an I. And then gas, gas, gas. When I was in the Army, whenever we put on gas masks, we were supposed to yell gas, gas, gas to tell everyone else that they need to put their gas masks on too. But anyway, here I have two types of nail polish remover. This one is 100% acetone, and this one has acetone and some other things. We're going to put them both in watch glasses and set them on fire. Here I'm lighting one match with another match, so that way I can light both the nail polish removers at the same time. Having different amounts of acetone should give us different reaction rates. You see the one on the right with less acetone starts to burn down a lot more quickly, but the one with 100% acetone burns out completely sooner, and it takes a while for the other one to burn out. In the alcohol burner stove, we have diethylene glycol. That's C4H10O3, and it kind of looks like this W shape here with all of our structures on there. And then we have our 5 oxygens, 5 O2 molecules, so 10 oxygens. And I'm sure by now you get the gist of what's going to happen. Here I have a little stove made of diethylene glycol. You may have heard of little alcohol stoves. That's what this is. So then I light this up, and it takes a little bit because it's kind of hard to see. And then I stand awkwardly off to the side. This is what's happening on a molecular level during a chemical reaction. So again, we have our carbon dioxide and our oxygen. But one thing that was interesting is while I was doing this, I had to replace some of my short little single bond things with some double bonds here. So that stayed aside, but I had some extras off to the side, and I'm just going to let them roll away. So you might be wondering, if everything balances out, how come I have extra bonds left over? Well, when we rearranged things, we had different kinds of bonds. Forming those new bonds released a bunch of energy, and that energy is what causes the whole fire and heat thing. Since oxygen is such an important part of a combustion reaction, just stopping the flow of oxygen, because it uses it up, stops the reaction. Burning paper is similar to the other reactions. Paper is mostly cellulose, so it has carbon and hydrogen and oxygen in it. So it's pretty much the same as the other ones, but it's a lot of fun to watch. It's very satisfying and pretty. Before I film this next part, I want to emphasize that I am a high school chemistry teacher, I have years of laboratory experience, and I've taken classes on laboratory safety. This is not a project you should do without competent adult supervision. Emphasis on the competent. I recorded what I was doing while I was doing it, but it was so windy it was hard to understand. So here's some table sugar I'm adding, and next I'm going to get some potassium nitrate and add that to my table sugar. It's really irritating to the skin and eyes, so I'm wearing eye protection and gloves. And so I'm going to add that to my sugar and spill a little bit, but that's why it's outside. Stir that on up, and you can see the potassium nitrate is like little spheres. So mix that up with my sugar. Then I add a little bit of water to make it a paste. I accidentally added a tiny bit too much, but that's okay because we have to let it dry anyway. So then I make a little mold with some newspaper and round a PVC pipe just for the size and tape the bottom. So I have my little mold for it. Then I add magnesium as a wick, because you can use string as well, but I wanted something that would be bright and pretty. So there's my little slurry paste. I'm going to let that dry, and then we're going to have our smoke bomb. Now here we have the chemical equation for potassium nitrate and sugar. Here is sugar. All this is one molecule. See, I wrote out the balanced equation here, but I didn't have enough supplies to make 5 sugars and 48 KNO3s and so on and so forth. So here's sugar, or sucrose. It's all one big connected molecule. And we have KNO3 over here. Now, potassium nitrate is not a covalent compound. See that when we share bonds here, remember that's a covalent bond. We have our nitrate over here and our potassium here. Our potassium nitrate is an ionic compound. So here's our potassium right here, and here's the nitrate here. You can see they're just going to kind of be attracted here. So you can see the nitrogen here is slightly positive, and you can see these two oxygens are negative. It's not very stable here, so the electrons are moving all around. So our potassium is going to be attracted to it. See, it's all positive here, and it's all negative over here, so it's going to hang out over here somewhere. And it kind of moves around a lot. That's why it's able to come apart easily. Now you might be looking at this and saying, hold on a second, we always started out with a bunch of O2 molecules with the other ones. Why don't we have that in this case? Well, we do have potassium nitrate, which is an oxidizer. Oxidizers intensify combustion and increase the flammability. Basically, it supplies its own oxygen. We have oxygen here and oxygen here already, and it makes the reaction get bigger. Oxidizers are used in rocket fuel. Oxidizers not only can supply the oxygen, they can also increase the rate of the reaction. They make it more intense. They're also super dangerous. Now here I am with a lit piece of magnesium, and it kind of sparked and wouldn't release, so that's why I dropped it like that. But it's been several days since we made the smoke bomb, so I had time to fully dry. You can see that it's smoking, and there we go. There's some pretty flames. And this is just the same thing from a different angle. You can kind of see the flames a little bit better here. You can also see the flames a little bit better that are towards the bottom of the smoke bomb. You can kind of see that it's starting to melt through the aluminum foil beneath it, which is why we have 2 aluminum foil pans and some sand and dirt between. We have a lot of sand, so mostly just dirt between. I had some leftover potassium nitrate, so I mixed it with water and did a little experiment art project thing. This dried fairly quickly, and then I set the edges on fire and it progressed along. I had 2 of them, but the other one didn't turn out quite as nice as I'd like, but then I had to take the flame to it a little bit anyway. It was a fun experiment. Traditional definition is reaction? Oh, that almost did a bad thing. Okay. Well, we hit the camera. Now we're going to talk about everyone's favorite reaction. Sad.
Stop doing that. Stop it, you tripod. Oh.
Okay. Okay, unrecord it. Stop. Well, the traditional Now we're going to talk about everyone's favorite reaction.
Sad.
Construction down the street, and they've been doing it all week, so what can you do? Can't talk. And the neighbor kid is making sounds like he is being murdered.